Welcome to Defn episode 14 part 2 or 15. I don't know how which number it is.
14A.
14A? Well, 14A is supposed to be the previous one.
14.1.
This is 14.2 then. Oh, we started 0, so 14.0 and this is 14.1.
We'll have to see. Yeah, okay.
Yeah. Anyway,
when we get up to 20, we'll stop this. But honestly,
I think once we get to 20, we'll just say the next episode of Defn. And because we're lazily loading these episodes, so we don't care about the indexes anymore because it's an infinite stream of things.
Exactly, we're just mapping over it.
It's a seek, lazy seek. Okay, so welcome to Defn, whatever the number episode this is. But this is a special episode because we don't have any guests, or this is not even a Village Idiots episode, but this is a special episode continuing on the previous part of this episode. We recorded.
Go on.
Don't interrupt me. I'm trying to find words, and
it's a trouble.
Yeah,
this podcast shit. Yeah. Okay, go for it. Go on. Carry on.
Yeah. So in this episode we have 3 new interviews that we did. Well, not new technically because we did that at EuroClojure, and we thought we couple them together and then release it as an episode. And in this particular one, we have 3 interviews. The first one with Malcolm from Jext, who is the
Malcolm
author of
Sparks. I think we should give him his full name.
Yeah, Malcolm Sparks.
Yeah.
Okay. Malcolm Sparks, and he worked. He is the author of the YADA framework for web application development, and we got to talk to him at EuroClojure, and then we spoke with Dragan Djuric, I think. He's the author of Neanderthal. He gave a talk about how to bring. The Clojure is not afraid of the GPU. That was the talk name, and he was explaining how Neanderthal works and all the magical GPU stuff that you can do with Clojure. We had a long, interesting talk with Dragan.
You know what was funny about that was that it actually broke into 2, didn't it? And I think he found out halfway through that
we're not recording. We were recording.
We were recording.
Yeah.
But didn't he find out that he had he got some confirmation or something about his professorship? So
he got a tenure.
Yeah, he got tenure. So that was like a momentous thing.
Yes.
During our interview, which was, I'm sure you'll remember it for that, if nothing else.
Yeah. And hopefully we'll get him. He already promised that he'll be doing a full episode with us, so we'll get to.
Yeah, maybe we should say that actually. That hopefully all of the people that have appeared so far, we were hoping to have back for a prolonged interview, because these were only like 15-20 minutes of interviews. So we'll hopefully get them all back at some point in the future for a longer, lengthier conversation.
Yeah, of course. And finally, we had David Nolen. As our last guest for EuroClojure, or at least last guest interview that we are going to make up, that we're going to release. And we got to talk with David, and he all sorts of things about ClojureScript and his work at Cognitect and ClojureScript community. So we were very grateful for all these speakers who spent their time with us at EuroClojure, and especially a special thanks to Lynn at Cognitect. She gave us support to set up our own small studio and everything and record all these things. So
thanks, Lynn. That was really great.
Yeah. And we hopefully get the videos processed pretty soon, because we not only just the audio, and Defn is now moving to kind of talk show level, I would say, for at least a brief period.
Maybe it's not the talk show though. Maybe it's a slightly better production values than we have.
Well, we have to start somewhere. But we hopefully will release the videos soon. We'll publish them onto our own YouTube channel, and we will announce them on Twitters, on the tubes, and everywhere else. All these interviews have videos as well, so you could actually see who is speaking. We did have a nice idea that we would swap our voices on the video. But I don't think
it still might happen.
Yeah, we don't know. Just to confuse people. But Anyway, so enjoy the episode, and we will get back to the regular schedule from our schedule. I don't know, American versus British thing.
Let's go for schedule.
Yeah, schedule is the British one, right?
We're European here. Yeah, come on.
Yeah, of course. We are on this side of the pond where things aren't right. The other side of the pond is pretty cussed up right now.
Let's not go there. Let's just not go there. Stay in the happy closure place. Parenthesis.
Yeah, let's live in the parenthesis.
I just want to add that there is a little bit of a sound quality issue on the recordings because we only had one microphone and we're passing a microphone around from person to person. So sometimes you hear the little clicks on the microphone, or maybe sometimes you hear people not speaking quite so loud as you'd like them. So apologies for that up front. We still think that the vast majority of the quality of the recordings is pretty excellent.
Anyway, enjoy the episode, enjoy the interviews, and we'll get back to the regular schedule from episode number 15, I think.
We'll make it up as we go along.
Exactly.
Just like the rest of this stuff.
Yeah.
Okay. Cheers, guys.
Cheers. So, Malcolm, welcome to Def and Talk Show, EuroClojure live edition. So this is the first time we're trying to record video as well, so it's going to be tricky. We hope it's going to turn out okay, but we never know. Anyway, so we spoke to John yesterday. We had an interesting discussion with him about his experience with Clojure, and he told us that you were the one of the guys who made him start Juxt and pull him into Clojure. So can you give us some idea about how did you start with Clojure and Juxt, and what are you working on these days? Some ideas about your projects.
Yeah, I mean, Juxt started, really the two of us were in separate banks and we didn't know of each other's existence, but we had very, very similarly named blog articles and we and so we sort of bumped into one another, and it was a time when we were, later on, and when we both left the banks, we could have decided, well, you didn't want to leave Clojure. We had Clojure teams. What do we do? So, and we kind of discovered Clojure was a really secret and a very effective weapon to solve lots of the problems they have in banks. So we thought, well, that might be generally applicable elsewhere. So, and that's why we started Juxt.
So now you're kind of doing Juxt, and that's I think that's a great thing of putting Clojure people in touch with the needs out there. But the project that you've been working on kind of mostly recently has been the Yada project. So it would be really good if you could give us just like a background of it. What motivated you to do it? What's the name? Yeah, why the name? So tell us everything. And you got 5 minutes, go.
Well, I mean, a lot of our projects in Juxt are of similar architectures. We love APIs. We love the integration of using the web stack and how that's driving a lot of the economy now and making integration between companies so much more viable. And so because it's such a common thing that we do, we want to be able to industrialize it and give people the ability to create APIs super quickly. And we think Clojure's a great platform to do that on. I'm a bit of an HTTP geek. I've been fairly disappointed by, I like to implement standards properly, and I feel HTTP is such a big standard, and it's almost impossible to ask developers and organizations to implement all of HTTP. In fact, they should be thinking about their application domain and not be protocol network engineers. And so Yada and similar libraries like Liberator are trying to bring web developers kicking and screaming halfway to HTTP purity. And also to exploit all of the advantages of HTTP that many people don't know. So that's the point of Yada, to make it quick and easy to implement HTTP, but in a way that doesn't sacrifice performance and scalability. So that's been why Yada's been taking me a long time to develop. I've been working on it almost 2 years, and before that thinking about it a lot. But it has been bit of a labour of love for me that I've been doing kind of whilst doing other project work. But it's true to say that a lot of our projects are in the trenches, and that's really the best place to, necessity is the mother of invention. So when we find that we need something and we build it, and we think, well, we need something like this in a more general place, we kind of go off and write it. And so that's really where the libraries come from.
Maybe you probably don't want to cause too much controversy, but what the hell? What was what was wrong with what was already there? And we can think about other languages or other stacks, but what's wrong with the kind of stuff that's already there in the Clojure system that you wanted to improve with Yada? What was the kind of the motivation for just doing something new?
I think a lot of libraries really let you start you at this kind of CGI interface where you get the request and then your job is to create the response. So there's not a lot of support for doing HTTP fully in content negotiation, conditional requests, caching, ranges, partials. There's loads of things in the HTTP specification. It's just so hard for people to implement. So that was the real motivation, to try and, rather than create it in a modular way where we pick and choose which bits of the specification we want, I really kind of try to wrap the whole of the specification in one library, so that you just use that library and you get HTTP asynchronously. So, yeah.
Okay. Do you want to? Okay, do it. Yeah.
So,
hold the mic.
No. So before creating Yada, so I assume you're using it already in your projects right now. Yeah. So before creating it, which stack were you using? And the projects that you're using, can you give us an example of a stack? Like, what is the database and what kind of solutions that you propose to your clients?
Well, before Yada, and it's not as if we're using Yada on all of our projects, and we're maintaining other projects that before. We used a whole mixture of things. We've used CLojureScript API from Tommy Riemann. We used a lot of Pedestal, actually, and the Pedestal interceptors. We've used Plain Ring and other things too, and Liberator. And it's partly that was kind of the drive of actually using all these different libraries that did different things. It was kind of, well, why can't we just have one library? So I just built another one. So now we have even more. But that was really the coming off a project where we had so many different ways of doing things. I thought we just need to consolidate that, because otherwise we're just going to have too many of these things.
And HTTP itself, especially from version 1 to version 1.1, there's been a static protocol, a static standard for a long time, but you'll know that it was recently agreed that there will be a new standard called HTTP2. Google have done a lot of work on this. It's being adopted by the browser manufacturers as well. Is this something, I'm kind of springing this on you, but what the hell? Is this something which you're kind of thinking about, or is this the kind of thing that you're going to wait a little while until other stuff settles down or infrastructure gets good, or what's your kind of feeling about HTTP2?
Yeah, there are aspects of HTTP2 which are more at the network level, and I know there's support for HTTP in Netty, which is the server that Yada is built on through Aleph. So that is the stack, and things like HTTP2 requires or pretty much requires HTTP-S and transport level security. But things like server push as well, that's almost at the network end. So there aren't too many things that have changed in the what's called semantics and content of HTTP that are that different in HTTP2. So I don't think it's going to be a lot of work to adopt it from what I've read of it.
Because I noticed from Google's side, for instance, they have this gRPC, and that seems, in terms of implementing WebSocket style interactions, because obviously the problem with WebSockets was that it was nice, it was a byte, you suddenly went to TCP/IP, you got a multiplex, you got very nice speeds up and downstream. But the problem was that you kind of lost a lot of protocol, you lost a lot of visibility, and everything kind of went away. So it's a valid thing to do because firewall-friendly things, WebSockets. But it seems like HTTP2 will standardize that a little bit. Is that something? Because that definitely seems to be changing the way that you program it at that point. Or maybe WebSockets aren't interesting at the moment. I don't know.
I mean, WebSockets is where you leave the HTTP protocol, and so you upgrade and you switch. And much of the impetus is to have very fast, low latency for message passing for games and so on. So, I've tended to ignore WebSockets and seeing that as a network upgrade. But I want to concentrate on things that are in the HTTP and HTML space, which is things like server-sent events. And server push in HTTP2 makes that, the pushing of content makes for a very very fast and performant low latency experience on the web. So it's possible that you can build very interactive experiences without requiring WebSockets, and with the advantages of all of the security, authentication, authorization that you have already built in HTTP, and years of known security and deployment issues that have been fixed. So I think there's a lot of value in HTTP, and allowing more people to stay within the fold is valuable.
So when people are writing their HTTP APIs, they often want to do documentation around them, and people using stuff like Swagger and stuff like that. Is that something which you integrate with as well?
Yeah, I mean, Yada does Swagger out of the box. You can just say, right, okay, I want to take this API and I want a Swagger document. And because Yada is very much data declared in data, the Swagger transformation to the Swagger description is just really a function transformation. Yada makes use of ring Swagger, which is Metasyn's library for doing transformation between prismatic schema and the JSON schema format that's used by Swagger. So Yada has always had support for Swagger. In fact, it was one of the first features I implemented when it was experimental. But I have mixed feelings about Swagger. It's pragmatically useful, but HTTP is really about dynamic discovery, and the point is to allow a user agent to discover new things about if the server does change, that through discoverability and observability, the client can say, aha, I know there's a link called foo, but now it's pointing at a different URL, I'll follow that. So it's really putting up signposts for the client to navigate what's new about a server. And that's not a new idea. Humans do that on Facebook. I mean, when Facebook do a new release, I think they do a lot of new releases every week. They don't have to notify everybody that there's going to be a new release of Facebook. You just cope with it. And so those coping mechanisms are built into HTTP by delivering links, by negotiating media types. And so in that world, it should be unnecessary to have out-of-band documentation through Swagger. However, there's an interesting thing that one of our Juxt associates, Oliver Hine, is doing, which is using the Swagger documentation as a media type in its own right, actually downloading it in clients and being able to utilize it to allow clients to call links and discover it. So there's certainly it's not a kind of clear black and white where Swagger is out of band. It can be used very effectively in band, which is quite a new and novel idea.
Yeah, I think. Do you think probably the whole Swagger thing and the whole REST API thing is somehow developers want to have let's say, an easy thing rather than a simple thing, or they definitely want something where they can grapple with, and the most popular APIs have been fairly static, even from Google and Facebook and Twitter. So more philosophical, maybe, this is a final question, because I really like, we really want to extend this conversation, during the podcast proper, if you would be happy to do that. But it would be nice to have a little philosophical question about, why is that such a problem, do we think? Why is HTTP itself actually is kind of like, failure is too strong a word, but why has it failed to sort of rest, and the whole concept failed to kind of grasp this, or why have the developer community failed to grasp this whole notion of this discoverability? Because I agree with you, but I also see it that in reality it just hasn't worked. Yeah.
I think it's really the answer to that question is more cultural. We want things now. We want we want our systems to be delivered in 3 weeks or yesterday, and we're the fast food generation, and we don't want to wait. And so that you get that instant gratification if you can get a document and hard code a URL for list of users or something. You hard code that, and then of course as soon as you hard code URLs, then if the server then changes, you've broken. So you're actually by adding discoverability into your API, you're paying it forward. Where you're getting the payback is in maybe 1 or 2 or 5 years down the line. And so, but I think it's because there's so much emphasis on doing things now, we tend to pay for it. With compound interest much later on.
So is this a perfect case for mortgage-driven development then?
Yeah, very much so.
Thank you for getting back, so you knew all this stuff.
Yeah.
Okay. Just a quick final comment, though. So that obviously you're the sponsors for the conference. Thanks a lot for that. And I'm guessing you guys are hiring probably. So yeah, we'll try to put the word out there. And you're primarily doing just Clojure, right? Yeah. So we'd love to have you on a podcast if you're interested, because I know that combined Juxt associate experience in Clojure is way beyond the roof, Yeah. So as we were talking to John yesterday, like he built this stuff a long time ago, 3-4 years in the Clojure world. It's pretty long time ago, because I used to follow his blog on Clojure at a bank and Clojure at a publishing house and all that stuff. So we'd really like to have you on the show, and thanks a lot for doing this, by the way.
Yeah, we'd love to come along and we'll do a nice long podcast next time.
Yeah. Okay, welcome to Def and Talk Show edition, live from EuroClojure. Dragan, right? Dragan, like Dragan?
Like Dragan, but not Dragan.
No.
In Serbian, it's more like David.
Okay.
So it's like the beloved.
Oh, sweet.
right, okay.
That's a very beautiful name, by the way.
For sure.
Yeah. You just gave a talk yesterday about the Clojure is not afraid of the GPU, and yeah, that was an amazing talk, by the way. So can you give us some background on why did you start this library, and and what is your experience with Clojure? When did you start with Clojure?
So I've been using Clojure for a long time, like since 2009. And since I work at university, it was mostly some of my research ideas, and you need lots of flexibility, lots of freedom to experiment, to not commit to a specific architecture or specific typeset or whatever. So I've been doing some exotic things in Java and I needed Aspect-J or some specialized libraries in, let's say, the beginning of 2000s, the middle of 2000s or so. But it was always like you wrestle with it for months and you're trying to create something that you don't have a place to look at, to literature. You have to find your way, but the language, the platform is great, but the language is quite rigid for some such stuff. But it worked kinda or so, but I always tried to implement some dynamical stuff and lose lots of time with it. So when Clojure was released, so it was, I think, the beginning of 2009 or so, I was regularly reading the most popular Hacker News or so. So I mentioned that there is increased interest in Lisp, and explored that. And when Clojure appeared, I tried it immediately, and it clicked. Yes, that was what I was trying to do, but in a much better than I would do this. So I converted almost instantly and started using it exclusively. So for years I was just using it casually. I had some ideas, mostly in machine learning and some Bayesian stuff, and so. But in the Java days, it was really difficult to see how to implement this in a way that you can explore, experiment with this, because the area itself is a bit difficult to get into, to experiment, to see what works, what doesn't. And I think Clojure is a great match for that. So then when I needed to implement this in Clojure, it was like, okay, Clojure is flexible. I have good idea how I would implement it. I created some prototypes or so, but I realized, okay, Java is fast, but now when I really have big demands for really large computations or so, now it's too slow. So basically, when you put on paper what is the number of iterations that you need to do, what are the numbers or so, you realize your algorithm is good, flexible, and nice, but everything but the toy problems would run in minutes, hours, weeks, months, years, or whatever. So then I started investigating about, okay, but there are people, it's C++, and everybody heard about GPU or so. There are people getting some speed increase with this stuff, but how it's done, and can it be done in Clojure? There were some experimental libraries, but not working. They didn't work that well. So I had to. Now you go down the rabbit hole. You fix one problem, and then you discover 10 other problems. So I realized that the libraries that were available at the JVM at the time, even some excellent featureful libraries, are actually not what I need, because they always try to satisfy the corporate Java world, to be Java-centric, to hide these high-performance features from the user, like to protect him. But in protecting the user, they just take away lots of performance and lots of flexibility and add many complex layers. So if you need to debug something or to fit it to your own needs, then it's really difficult. So I realized I have to provide some.
So you're working on this Neanderthal library, and that is part of your whole uncomplicate umbrella. Yeah. So can you tell us something about the library? What are your plans for the library, and why did you start this thing? Is there a commercial project or something, or is there something that is a use case that you're going after?
Yeah. Well, so basically, I have some ideas of how I would use Bayesian machine learning or data analysis commercially, or some of it would be open, some of it would be part of some service, some long-term plans. Why I needed basically Neanderthal is free, open source. Works really well. I have some feedback from real users who are excited. It works really well for them, and I'm on this long time. So I have such luck or to have freedom to not be a startup that needs money and have some short runway, or have to provide something in 2 months, so they need to rush it to just work somehow, but don't be really well polished or so. So I have time to dedicate to this. So sometimes I have something working well, but I realize that there are some points that could be improved, and I spent 2 or 3 months just to get it really right, and that's why I think it could be really useful for a lot of people, because I will certainly develop this for years. So basically, and I also, this is not the only stuff I work on. So basically, I completed the stuff that is the most important that I needed. There are stuff that could be implemented relatively quickly. It's ready. The infrastructure is there. The native libraries are there. Yeah, I know how to connect to it. I know how I would implement that. I didn't want to rush it because I didn't have the concrete use case. So it depends on the interest of people. So if I see that people want, okay, I really need this functionality, I need for my application, especially if they can help or provide some code or contribute some funding so we can develop something that is, for example, more polished or more documented or whatever. So there are many opportunities on that. So basically, if you use this, you don't have to be afraid that I will forget about it in a month.
Just on that subject, are you actually, because you're a professor, so are you thinking about, like, are any of your PhD students or anything like that interested in fields where they can use this kind of technology and maybe also contribute and add to it, or is that the sort of thing that you're looking for, or yeah?
Well, there are some PhD students experimenting with this, and some master students experimenting with this. But I think the point is that I don't think at this moment they can help much, because all of these people have their day jobs, so they cannot dedicate too much time to this. But
Prove it out, though. They can help to prove that it works.
yeah, of course. But the point is, I don't run away from coding. I actually like coding, and I'm not some professor who have 10 PhD students and then just have some bright ideas and then just put it to the workers. I do everything myself, and I think that's why Neanderthal is quite easy to use, because I use it myself. So I create this for myself. So that's why it should be easy for developers. So that's it.
There was one question I was asking you before, which was about the like the tool chain for all of these things, because whenever you get into this really high performance computing stuff, when you're going bare metal and all this kind of thing. Well, actually, maybe there's two parts to that. Actually, it's like, I guess we're really talking bare metal here, and that virtualization is not a great idea, or are you kind of like on the fence about that? Obviously, Amazon runs virtualized, but then if you get to that core CPU, whether it's virtualized or not, people have to often include native libraries and all these kind of things, which makes the tool chain a bit more tricky for standard Clojure developers. How do you think that can be addressed?
I cannot give a specific answer because I don't use it myself on containers. But I suppose because, let's say, if we counting developer machines, let's forget about virtualization at start. The thing is, it's one of the main values that Clojure adds here. I think it's pretty much easier than using this stuff without Clojure. So for the native part on Mac OS, for example, you just need to have your development machine, and Neanderthal will work out of the box. So you don't have to do anything special if you have development environment set up for Macintosh programming or so. So it works out of the box as any other Clojure or Java library. On Linux, you have two options. You either want it to be optimized for your machine. In this case, you have to compile Atlas native library. It's automatic. It's not so difficult. It's a make and standard C stuff. But it could be a problem for people who didn't really do that. So there is documentation. It's clear, but some people might be afraid of it at first. But luckily, I think all major distributions provide Atlas as a package. So maybe it will run at 70% of speed, or 90% of speed, or 40% of speed, depends on how your machine is close to their machine where they compiled it. But it will still be much faster than Java stuff. And the point is, there are lots of algorithms in native libraries. You don't even have them implemented properly in Java. So that's one door where we can get amazing functionality, like decades of development and optimization, basically for free, with no overhead, with some pleasant API, with lots of functions that feel like Clojure. So you don't lose much. And there is a third part, which is actually the most awkward. It's Windows, because I don't use it. I don't use it for a long time. Actually, I don't even use desktop. I use window manager, so, and I don't have a mouse. But the point is, on Windows, it's a bit more tricky, but now it's not difficult, because if you send me an email, I will send you my libatlas.dll. So it's not a problem. And you can also build it yourself. This is the native part. So if you want to really put it on a server, I guess, in virtualization or so, I guess you will see how native libraries themselves work on that. And I suppose because all software that uses those also works on virtualizations, virtual machines. So I don't see that there could be any issue there. Maybe you need to configure something in VM or do some stuff, but there is documentation. People already do this. As for the Neanderthal stuff, if JVM works, it will probably work. The GPU stuff is a bit different, because to use GPU, obviously you have to have drivers for that GPU. So it depends on the vendor. If you use Intel, if you use NVIDIA or AMD, depends on which operating system you have, how stable the drivers are. But pretty much it's useful today. So depends on your specific case. There could be more or less some need to experiment. But basically it works well. It's not as stable as standard server software for CPU, obviously, because it's exotic hardware. But if Google uses it and don't have any problem, I suppose that it's mature enough that you can create a new novel algorithms or so for it.
Yeah, I'm pretty sure you're right. I'm just thinking about talking about Google there. Some of the stuff they're doing in terms of and this whole you tell me whether this is in your kind of space, is the TensorFlow and the OpenAI stuff. Is that the kind of thing which you're hoping to target on some of these activities?
Well, it seems that you're really well prepared, because you're asking the right questions that I would love to answer. So are you have you prepared for this, or you're just improvising as well as I do?
We're just improvising. We'll prepare more for a longer show. We have you on the podcast. Yeah.
No, no. The questions are really the right ones. I couldn't think of better questions. The thing is, now, as I see, I don't have any connections to Google. I don't know anyone who has some position, some important position in Google. So I don't know what do they actually plan or think or whatever. But what I can see, and probably what you can see, is that TensorFlow and deep learning is now like the most popular machine learning stuff. That 99% of people who are looking into this stuff, they are like looking, okay, deep learning, I can create some terminators with it, or some kind of some kind of artificial intelligence that will work while I'm sitting on a beach, or lying on a beach and just taking sunbath. But I don't think we are even close to that.
That's good.
The thing is, the thing is, I think Google and Facebook and NVIDIA and those powerful companies, they now they have several use cases that work really well, like image recognition or so. It worked really well, and but mostly to be successful with that, you have to have lots of data, and that's great. I think many more use cases fit into it, but not all use cases. So me personally, I'm not very interested in deep learning because I think there are lots of people working on that. There will be lots of good results. There are lots of good results. It's working fine. Let's see what the hype will produce. And it's not only hype, lots of useful real stuff is there. But there are also cases, especially with smaller companies, with exotic use cases or so, when you don't have big data, you have small data. Like you don't have 100 billion photos, but you have 100 data points about something. And Bayesian methods are actually good for that kind of problems. And Bayesian is also quite exotic. Now, lots of people are kind of interested, but not much technical output is there. So I think with Bayesian stuff, I understand this problem more. I understand the area more. Maybe it's just my personal preference, and I also seek how I can use it for some specific stuff. And I hope, and also the competition is much weaker there. So I hope while all other people are working on deep learning problems and big data, I'm working on Bayesian stuff and small data. So when this kind of application come to on the spotlight, I will have lots of solutions that already work, and I will be able to provide some real value. So that's some kind of general plan for these libraries, Bayadera especially.
Yeah.
So, sorry.
No, I think we're pretty much done.
No, that's okay. Yeah.
It's awesome. Yeah, it's really good.
So, of course, I mean, we're going to do a full episode with you, and then dig deeper into all the libraries that you're building, and probably there is a lot of interesting stuff going on, obviously. So this is your first time at EuroClojure, or were you before, or so? First time. Oh, okay. So how are you enjoying EuroClojure as a final question?
This is my first, not only EuroClojure, but it's my first developers conference. Because previously, all the conferences that I went to were like academic conferences, lots of people. Everyone was presenting their work, ideas or so. But I actually like this way more because there are not 1,000 talks. There are only a selected 10s or 15s, so you can concentrate, like hear what people do, talk with other people. There is the atmosphere is much more focused and also relaxed. So you can find people who are already interested in the stuff that you work, so you can share the experience. And actually, what is interesting for these exotic libraries that I presented, like there were like 15 or even more people who approached me and says, "Oh, that was interesting. I think I can use it in my startup or whatever work I do." And I was trying to do this, but I couldn't succeed before. I see how this could benefit me or my friends. And most of those people didn't really know that there are other people in Clojure conference. For example, there was this guy who has some company in Germany and Russia or so. They actually don't do Clojure or just started doing something, but they do GPU with NVIDIA and so in C++. So he was like, I was chilling, and he didn't look at the talk list. So he scheduled, so he didn't even know that there would be GPU stuff. So he was like, "Oh, awesome! This is the stuff that I need to understand or so." So there are lots of people who are interested in this who are not aware that there are lots of other people in Clojure community that actually want to try this stuff. So it's an important point. You're not alone.
Yes, that's good, yeah. Right, well, thank you very much, Dragan. Great answers, and like Vijay said, it would be really good to have an extended conversation over the podcast, so it'd be really good to have you back on there. But I think we should stop now. Right, well, here we are. Different podcast talk show type thing. David Nolen in the house.
Hi.
Thank you very much, David, for coming along. It's really an awesome honour to have you here today. You've given your talk at EuroClojure now. It's all over, so you can relax, have a few beers, or whatever. And we just thought we'd have you on here just to talk about a few things to do with growing the community, that kind of thing. So sort of open question really about how do you think we can? You made a few comments in your talk about this. But what do you think are the big hitting factors that we can help to grow the community from the Java people, the Clojure people, the JavaScript people, that kind of wider community of people that are kind of curious about functional programming, but maybe aren't quite there yet?
Yes. So that's a great question. I think, when it comes to programming languages, when you're sort of starting out, you have to convince people to use it when you have no users, right? When you have no users. And often programming languages, they cater towards the sort of language geeks, like you have a cool feature, immutable data structures, functional programming, all these, that's what gets the people to try it out. You're offering something that other languages don't have. But I think in order to sustain the growth of a programming language, eventually you're gonna have to be able to reach out to developers that maybe aren't really interested in the fanciest features. They really want to solve typical problems. They want to know how your technology helps them solve typical problems. And I think there's a huge hurdle. At a certain point in in the life of a programming language, people want to know, show me something that you've done with this. Show me that you've done something with this. Show me products or applications. Show me that you've been successful with the technology. And now that we're this far along with Clojure, you go to these Clojure conferences, and it used to be I would talk to somebody like, do you use Clojure? And they're like, late at night when I'm hacking. And now, people are like, yeah, I use it at my job. I've been using it for 2 years, and we've built a great project with it, and we've got new projects in the pipeline. And at that point in a programming language, this life, you really want to take a moment and say, okay, we know it's succeeding. We know it's good. How do we grow our user base? How do we reach out to, this wider group of developers? Because again, you can't just focus on people that are looking for just going for cutting edge features. That's not enough for, I think, the bigger audience.
Yeah. Vijay?
Yeah, so one thing I wanted to ask is that, so you're now spending a lot of time on building CLojureScript. And so do you also do consulting along with writing CLojureScript to different customer projects, or you're primarily full-time working on CLojureScript?
At Cognitect mostly is, does consultancy work, but they're also a product company, and and the product that they have is Datomic. I'm actually on the Datomic team. I do I've occasionally spent some time to help out on the consulting side with consulting projects, but most of my time is spent working with the product team. I do, of course, spend a lot of time continuing to steward and guide the CLojureScript project. And that's, it used to be that I would do a lot of work there, not just, actually write tons and tons of code. But these days it's been great. I mean, there's more contributions now than there have ever been. And a lot of my time is helping other people succeed at contributing to CLojureScript. And I think that's also a huge factor in its future success, that people beyond, just me at Cognitect or a couple of the people at Cognitect understand how CLojureScript works fundamentally and are able to make significant contributions and push the project forward.
Yeah, I think talking about contributions as well, to get us back on track. Because it's the kind of thing we should do. We were talking about contributions, and we saw this talk from Maria last year when she was talking about the Google Summer of Code, where she added the support for modules, I think it was, into the CLojureScript compiler. That seemed like a huge move forward in terms of interoperability between ClojureScript and JavaScript. We see that with other languages, that seems to be the big thing, which actually is bringing the JavaScript people in to the compiled to JavaScript ecosystems. So it seems to be a barrier for Elm for some reason, because they want to have like ports and stuff like that. Do you think we can go any further than we have already in the ClojureScript? Not necessarily you, but other people in the community contributing. What kind of things do you think we could do there to make it a bit easier to consume libraries or to reach out to existing JavaScript libraries?
So that's a good question. There's actually a lot that we can do, and I've spoken about this a little bit, but we also have to be very realistic about the limitations of what's possible. I mean, one fundamental limitation is that ClojureScript uses the Google Clojure compiler. And when you sit down and you write a ClojureScript library, it absolutely is ready to be consumed by Google Clojure. Google Clojure can optimize it. It can dead code eliminate it. We produce the perfect code for it to consume. But people that write typical JavaScript libraries, they're not used to this idea of advanced compilation and getting highly optimized code splitting. They've never had it, and they don't know the value of it, so they don't feel compelled to write code in a way that's easy to statically analyze. So at a certain point, there will be certain libraries that just won't work that great, right? There's nothing we can do about that. That said, it's surprising how many libraries that people write that are actually don't involve a lot of metaprogramming, that are written mostly as static style. It's really surprising. People tend to write pretty boring code, which is actually something that Google Clojure can understand. So Maria's project is a huge step forward in saying, in the universe of JavaScript libraries that are out there, I bet 30% of them can pass through Google Clojure without a problem. And we would like to make that stuff far, far, far easier to consume. I hope it's clear that we take interop extremely seriously, and there's that initiative it's basically in alpha status, the JS module processing, and just recently we landed a patch in the current release that updates our support for that, and people have tested it out, and it works pretty well, and we want to hear more feedback, and we want to make it better. So yeah, we want the JS interop story to be really great. But people do also understand there is a limitation to what we can do based on the fact that we can't convince the entire JavaScript world to change the way that they write code.
Just one more point on that. I guess it's about benefits, isn't it, at the end for that kind of stuff? Because dead code elimination, people often think on the server side it doesn't really matter. Whether you ship 400 megabytes or 300 megabytes, it's 100 megabytes. It doesn't really matter. But when you're shipping JavaScript libraries, and you can bring it down to 2K or 10K rather than 2 meg, that's going to work a huge amount of difference, isn't it? And that's the kind of thing you can really sell if you're giving people that kind of win. It's not necessarily a performance win in the sense of raw numbers on a GPU, but it's a performance win from a usability perspective and a time to function kind of perspective. Do you think that's the kind of thing which could potentially, like, the JavaScript guys could leverage a little bit with ClojureScript, that they could bring that story out to bear a little bit?
So that's another great question. I mean, we do have to remember that while I think ClojureScript has somewhat of a different philosophy about what the best way to go about programming for clients is, the truth is that most JavaScript developers are experts with respect to page load time latency. So they are concerned about this problem, and people have done all these studies. If your web page takes longer than 1 second to load, chances are people don't actually wait. They go off. So performance is critical for engagement. So they are very aware of this. But I think what's happened is as the JavaScript community wants to build more ambitious applications. They want to bring in React, immutable date JS, Lodash, Moment.js, high charts, and then suddenly their JavaScript application is 2 megabytes, and even with their Webpack and their compression methods are like, our JavaScript is still a megabyte. It's a gzipped, it's a megabyte download, and it's because again, there isn't this wider discipline ecosystem to support things like dead code elimination and code splitting so that I can manage that. And I think that's why we've come out of necessity, right? It's because, like, if you look at the ClojureScript standard library, it's 10,000 lines of ClojureScript. ClojureScript would have been more or less a non-option.
Like dead in the water.
It would have been dead in the water if we did not have an answer to the fact that we have a very large standard library. So out of necessity, we decided to go with Google Clojure. And I hope that as the wider sort of JavaScript community understands it, that we could be, that could actually draw people who aren't necessarily, their interest is not in like JavaScript or ClojureScript. They're like, oh, I really want to solve the UI problem as best as I can. And actually, ClojureScript lets me leverage JavaScript libraries, and then that is a really nice language. And I think there's a kind of a large audience there of, I would say, UI programmers who don't necessarily aren't obsessed with JavaScript or not JavaScript, that just are looking for the best tools to solve the problem. And I think if we focus on that group, I think we can make a lot of inroads.
So you're leading the ClojureScript project, and Richiki is leading the Clojure project essentially. So is there any situation where when you guys are thinking together that, okay, there's going to be a new feature that we want to add into Clojure, oh, wait a minute, we need to think about whether this can be ported into ClojureScript. Are there any hurdles like that, or did you ever find yourself in that situation?
So that's a good question. I mean, Richiki wrote ClojureScript, so he's pretty familiar with the limitations. Although sometimes, he doesn't actively work on it, of course. So he'll implement something. But fortunately, I'm there at Cognitect. When Richiki comes up with an idea, I'm there. Other ClojureScript developers are there, and so we'll often chime in and say, we'll ask questions. What are the repercussions for something like ClojureScript?
For instance, was a very interesting example, wasn't it? Where, what are you going to do in JavaScript with core async? It's already single thread. Maybe there is something.
Yeah, so core async is a great example, though he already knew that he wanted that to work in ClojureScript, so he'd already planned that one pretty well.
That is reducers then, or transducers.
So transducers, again, also very clean to port. Actually, ClojureSpec is actually a case that was pretty challenging,
Right.
because there's a bit of metaprogramming in ClojureSpec, and we can't faithfully port specifically some of the testing functionality, but we can provide something that's good enough. So some things that are functions in Clojure, they have to be macros, but of course these come up in discussion. They have to pick a certain design, and I'll be, well, that's great. Is it okay that ClojureScript's going to be a little bit different from Clojure here, in that we'll have the same API, but we'll have to have documentation that's clear that these things aren't functions in ClojureScript. They're functions, macros in ClojureScript.
We're having some fun with the screen.
Sorry about that, by the way. Well, it's a blue screen, so we can change it to anything. That's much better.
We've taken up a lot of David's time, haven't we?
Yeah. So I just want to ask you a quick question about. So you're in a band, right? You go around the tour, and so can you give us some idea about what you play and that kind of stuff about your band?
Yes. So I don't actually have a band currently. So I did have a band like about a year ago that was sort of active, and we did some stuff. But in the band, I played guitar and I did a little bit of singing, and I've been playing music for a very long time with some very good friends. Right now, I'm in between bands, so to speak, but I do have people that I collaborate with. We work on music together. So that's still happening and still active, but there's nothing for me to speak about yet. It's still like in the gestation. That's right.
Yeah, that's magic. Well, yeah, that's really good. Thank you very much, David. This is our first venture into this stuff. Fantastic to have such a great guest as yourself. Really honoured to do it. Thank you very much. And you get a free mug on the back of this, okay, which is really great. Yeah.